We move now to a little different branch of wind, which is airborne wind. We had a presentation in a couple of editions ago of a specific company, and this time we have the organization which tries to combine all the companies working with airborne wind. So I would like to welcome Christian Patrick, who is the Secretary General of Airborne Wind Europe, and he has a lot of experience in policies and strategic advices both for public and private sector. And on top of that, he is also involved as a Airborne Europe in the IEA Task 48. Christian, are you there? Yeah, I can see you sharing
Yes.
this already.
Can you hear me?
Yes, perfect. Welcome.
Okay, great. Yeah, thank you very much for the introduction, and thank you very much for inviting us to this conference. Indeed, we are somehow different, but we are also considered small or medium at this stage, and I will explain a little bit further what airborne wind energy means and where we are currently. This is just an overview of the association. We have about 20 members, of which some 12 are developing the different airborne wind energy systems. We are a member of Wind Europe. You already mentioned that we have our own task within the IEA Wind TCP. And then you see here that we are also members of a number of other networks, among others, the Alliance for Rural Electrification, because our systems will actually have one of the main entry markets in the off-grid and distributed energy markets. And I will also explain that in a moment a little bit further. So I will give you a short overview about the principle and concepts, the advantages, markets, and the current state of the industry, and then briefly discuss demonstration commercial side that we are looking for. And I'm happy that Ignacio was presenting just before me, because we also actually visited CIEMAT almost a year ago, the site in Soria, to see if that would be a site where potentially airborne wind energy systems could fly. So let's see if that will become a reality in the near future. So our technology consists basically of two main types, where we see that there's some convergence. There will be soft wing systems that are like big kite surfing kites that you see on the upper side, upper row, and then fixed wing systems that are more like drones or small airplanes. The principal power generation concept is the so-called ground generation or yo-yo principle, where the kite flies out in figures of 8 and pulls a tether, which is wound around a winch. And then next to the winch, you have the generator on the ground, which produces the electricity. At one point, the tether is reeled out, so the kite has to fly in again to the starting altitude, and you need a little bit of energy and time to reel in, but it's much less, so it's about 15 to 20% of the total power that is being produced during the reel out phase. So, but yeah, you have this yo-yo principle or pumping kite system, which can be applied for both soft wing and rigid wing systems. Then the other type of generating is the so-called flygen, where you have the power generation on board. That means that you fly like a drone, vertical takeoff, you fly into the wind, and then you start the figure of 8s, and you turn the propellers and the motors basically into generator mode. So you produce the electricity in the aircraft and evacuate the electricity through the tether to the ground station. There are currently 2 companies that are pursuing that concept, and we will see which one under the fixed wing systems will actually be the one that will be further deployed in future. But both are very promising. Now I will show a short video, and I hope you will see it there as well, of the most advanced system, the SkySails power system, about 150 kilowatt in Mauritius. So that's the first commercial system, basically. You see the automatic launch from a mast, 15 or 18 meter long mast, from which the kite is being launched. It's going with the wind up into the air, and then starts the power cycle in figures of 8. So you see that this is a containerized solution. You basically have a very small ground station. You even don't need to put any foundation because the ground station is heavy enough to withhold the kite. So there's there's nothing required except that it's a rather flat area. Here they put some concrete apparently, but it's not so much. And then, in case there's no wind or you get a hurricane or anything like that, then you would pull down the kite and land it again. And that also can be done automatically so that there's no people involved. Not all companies are there yet for full automation, but the majority also for the fixed wing systems can do that already. And all of them will have or will be full autonomous in future. So what are the advantages of airborne wind energy? The first advantage is that we get into higher winds at higher altitudes. Here you see the wind map of Europe at 100-meter fixed height. So basically the normal height of the nacelle. And you see that the best wind above 7.5 meters per second in the reddish colors is basically all offshore. But we all know that there is also wind turbines onshore. But now if you go or can go up to 500 meters, then you see that you get basically offshore conditions also onshore. And this is a major advantage of these kind of systems, because as you know, the power output increases to the cubic factor when you increase the wind speed. The other big advantage is that we need up to 90% less material, because we only emulate basically the wingtips of a conventional wind turbine, and we get rid of the tower, most parts of the foundation, and the blades. And that's the other big advantage, because that gives us potentially lower costs in future and many advantages also in the supply chain. So under the circular economy approach, we basically reduce from the get-go a lot of the materials, and wind energy we know is already quite good, but we can even be better by reducing further. That will help us, these mass scalings that you see that are required in the future here from a JRC report on the technology-specific materials. So these are also rare earth materials. And then, but also structural materials like concrete and steel, they will all be a factor 10, 15, even up to 40 required to build up all the capacity that we will require for onshore wind or on and offshore wind. So if we can help to reduce a little bit this material amount, then that will be definitely advantageous. And first studies also show that since we have in most of the systems the generator on the ground, we are not, we can use heavier materials or don't need rare earth materials for the generator, which has other additional advantages. Then a recent study even showed that onshore airborne wind energy significantly outperforms onshore wind turbines just because of this higher capacity factor. We have to see how to deal with that in future, because we are not there yet, and we need the same amount of capacity per square kilometer, where the systems are not at this size yet. But you see that in future there will be, this decision may have to be taken for certain sites, if it's more advantageous to put an airborne wind energy system or a horizontal axis wind turbine. So markets are basically all the markets that normal wind could go as well. But since we are logistically easier to handle, especially off-grid and remote areas, or mines are definitely markets where it will be of interest. But then also floating offshore, because also here the material advantage and the reduced logistics will help to get into deeper seas, because we basically just need a landing platform and just smaller platform basically without the large towers out there in the sea. But this is still for the future. At the beginning, all companies are focusing on onshore. So yeah, that's another way of showing it. Basically, this replacement of diesel generators in remote areas is one of the key markets at the moment. As long as we don't have specific support schemes for grid-connected systems in Europe. So that's definitely something that we are trying to achieve, that the different member states of the European Union or other countries give us either feed-in tariffs or CFDs or whatever is required, or what PV and wind also received in the beginning of their well, until recently, or still in many countries. And we need that specifically for airborne wind in order to be able to enter into the market and to upscale. At the moment, we are about 20 cents per kilowatt hour. So that's also the feed-in tariff that we kind of ask for at the moment. And we will see if some countries, we are especially active in Germany on that, will go ahead with that, and hopefully we'll get this to connect more systems to the system. But yeah, you see that 20 cents, or you know that 20 cents per kilowatt hour is already lower than diesel-based power generation. So in remote areas, we would be, or we are already competitive. So where do we stand right now? Just an outlook, well, or basically a status how we are seen. Most, or basically all major studies that consider airborne wind energy from the European Commission, from IRENA, NREL, UNFCCC, all say that this is a promising technology which should be further explored. So it's not that there's not any report out there on an official one that says this is a dead end, but actually all of them see potential, but they all also say, well, more needs to be done. So we need further R&D support, but also a market price support, as I mentioned before. The advantage for Europe is here that most of the organizations that work on airborne wind, so both in terms of technology development, but as well as research, are in Europe. So we have basically an advantage here. But there are also a number of institutions in the US and also Japan and other areas. We are not really sure what's happening in China. But yeah, basically in Europe, we should try to keep this advantage, hopefully, and build up a new sector for airborne wind energy in Europe to have a competitive new technology here. There was very briefly, you have seen already the IEA task. So we are the task 48, started about 2 years ago with these 5 work packages. We have 11 countries that support us, and any other countries here in the call or institutions who are interested are willing or are very welcome to join. See resource potential markets, reference models, tools, metrics. Some of these points that Ignacio mentioned are also part of that. Safety and regulation is definitely very important because we are flying up to 6, potentially close to 800 meters. So we go into the airspace and have to share that airspace with other airspace users. So we have to deal with that, and we have make some proposals on how to organize that. If there are questions on that, I'm happy to reply to that later. Social acceptance is very important for us. We don't want to run into the risk that that there are a lot of people that say, well, we don't want to see that. So we want to avoid what is partially happening with the wind sector, that people just don't want to have us. So we want to be very open and transparent from the very beginning, and hope to get support there also from local population involving energy communities and so on. And we are working on several life cycle analyses within Task 48, which will, a few are already published and some more are to be expected in the next months. Last year, we published a white paper commissioned by us, but written by an independent consultancy, BVG Associates, about the future of airborne wind and the roadmap, so to speak. You see here that we could, if we have the same upscaling curve as conventional wind had from 85 to 2010, starting in 25 for us, we would reach several hundred gigawatts in 2050. We think we can also already, well, the last year, basically, we think we can even be more bullish on this one. But yeah, we have to get on this curve, and therefore it's important really to get political support. And then for the cost, the same, we can run down pretty quickly, we think, on the cost curve if we have the right support schemes in place. There are some opportunities currently with the Renewable Energy Directive. I still have not exchanged this year, so it's now defined. It's not only will likely define, but it's there now in the new revised directive. There's a 5% target for innovative renewable technologies, and we think we are, or we can help achieving that target because we are definitely one of these innovative technologies. So we also hope to get into the NECPs, which are due in their final version middle of next year. Then there's this European regulation for unmanned aircraft systems, which also helps at least the fixed wing systems to be quicker deployed in different parts of Europe, because if you have a permit in one country, then you can do a transporter permitting procedure and then rather easily go into another country if you operate under similar conditions. And then this current focus on faster permitting will hopefully help us as well, because acceleration of another renewable electricity deployment is something that is urgently needed. Then briefly on the demonstration and also actually commercial sites. So we are looking for sites in Europe in order to reduce also the logistics. Well, basically that's the small teams that are working on these systems have to travel too long. So we are looking for these sites in Europe at the moment. Just 2 days ago, the site in Ireland was inaugurated under this Mega-Ore project, this Interreg project that you see here in the top logo. And there will be hopefully more to come over the next years. And these sites will help us to optimize the systems and then really deploy globally with a lot of potential for export and in all these different fields that we think are potential markets for us. Just to get an idea, what we are looking for is basically rather flat areas. Well, they can be also hilly as long as there are no major peaks or no high structures in there. About 800 to 1,000 meter radius around the ground station. But there are also systems that are flying with shorter tethers, so it can also be potentially less. But we need something where you don't have roads or other buildings or so on, just in case the kite comes down. So that's, we're getting safer and safer, but you never know. So it's important that we don't fly across any roads or anything. But agriculture and things like that can still happen underneath. If you have a bigger site, then you could also, then you wouldn't place the systems with, 2 kilometers distance, but you can pack them closer to each other because you can steer the kites in a way that they are flying in a synchronized way, or, well, at least in a way that they don't entangle the tethers. So that will be all possible. We have just done recently a study for Germany on the airborne wind energy potential. And under these different conditions that I just mentioned, we get a potential of between 12 gigawatts and even up to 100 gigawatts with shorter tether length. So we have to see where we end up, but it's not that even in a country which is very densely populated like Germany, that there wouldn't be sites available. That's actually, there are quite some sites where these requirements are being met and we could be deployed. So to end this presentation, 3 main points to take away. So we may be the single most important new renewable energy technology because we tap into this high altitude wind that where no other technology can tap into. So we think that this is really a major opportunity for Europe to be setting up a new industry in that field. We are reality, so we have the first commercial systems available. We have basically all the systems have shown that it works, and there are no technical or other major showstoppers anymore. So everything what is now required for deployment can be solved, as it could be solved for other renewables as well. And we require political support because that can speed up the airborne wind energy potential. So this public funding will be required for research, but also for remuneration of the power produced. Again, we also think that there's no major risk for policymakers, because if we don't produce so much, then we also don't receive so much money. But there needs to be political support, and that's why we say ideally we would develop an European airborne wind energy strategy together with the government's agency, the European Commission, and us as a sector to see how this technology can really make a major impact. And with that, I will finish my presentation. You see here real projects in the different countries and islands. And if you have any questions, please let me know. I'm not sure if we still have a few minutes because we are run over time already, but I am available.
Thank you, Christian. So if there is any question, please come in. Yes, we have a question here from the audience.
Yes, I have a question about the maintenance cost of the system, because we have a not durable system in, let's say, the wire, the rope, and the kite, and you can't maintain these things. You have to exchange them. So the first question is, how long will they last for the exchange, and how high are the costs in the maintenance for the overall lifetime? Thank you.
Yeah. So indeed, especially the soft kites don't last forever, and the tether neither. So Sky Sails, for example, they think that kite may last some, depending on the conditions, depending on the wind conditions, maybe 9 months to a year or so, and then it would have to be exchanged. And the tether the same, so up to a year maybe. Potentially, at the moment, they think they would exchange the entire tether, but further going on and optimizing, maybe only the lower part needs to be exchanged, because that's the part that constantly runs around the drum, and the upper part is basically not being used so much. So indeed, these costs need to be factored in the LCAs. They are factored in, and then they are also factored in the LCOE calculations, and they are potentially higher, at least in the beginning, compared to conventional wind turbines, because we need more operating hours and see if it really works. And you need, especially in the beginning, also due to permitting, you need people on site who can bring down the kite in case there's something happening. They don't let you fly without having someone supervising it, but all these are things that in the future will hopefully disappear. So then these operating costs will go down. But yeah, they may be potentially higher than for conventional wind turbines. Just mention that this exchanging of the kite is not necessarily a disadvantage, because in the meantime, better kites are being developed. So you can always exchange the old kite with basically the last generation of the new kite. So you could even upgrade systems slowly over time, leaving the ground station at the same capacity, or making the ground station basically set of that can only deal with 150 kilowatt. You may already put one that can deal with 250 or 300 kilowatt, and then you increase the power of the kite over time and the performance. So that's actually an advantage of this cycle. And the fixed wing systems, we will have to see how long they last. Maybe not 20 years, but they are supposed to last quite a lot longer than a year.